Let's look at 3 different processes and see if we can figure out which has the greatest enthalpy change. So A, I'm going to take solid ice water at -10 to liquid water at +10 Celsius. B, liquid water at 0 degrees Celsius up to liquid water at 100 degrees Celsius. Or C, liquid water at 100 degrees Celsius to gaseous water at 101 degrees Celsius. Think about those 3, which requires the greatest amount of energy. Let's look at a possible explanation for each answer. A, melting ice is a phase change that requires the greatest amount of energy. Or B, has the greatest temperature change, so it requires the greatest amount of energy. Or C, the gas to liquid phase change requires complete dissociation of intermolecular bonds and the greatest amount of energy. Think about those 3 and make a selection. We're talking about the heat required to do some physical and temperature changes on water. So the first change was solid water at -10 going to liquid water at 10 degrees C. Now, the major change there is the phase change, going from the solid to the liquid. And that requires about 6 kilojoules per mole. Now you can calculate the 10-degree change in the water here and the 10-degree change in the water here, but you'll find that's just a few joules. So here I have the next step, liquid water at 0 degrees C going to liquid water at 100 degrees C. And you might think that great temperature change would require the most heat. But we can do the calculation with the heat capacity of liquid water and the temperature change, and we find for a mole of water that requires only 7.5 kilojoules. Pretty much the same as melting the water. Now the third step was taking water liquid at 100 degrees C and going to gaseous water at 101 degrees C. This requires the heat of vaporization to overcome all the intermolecular interactions in water and go from liquid water to gaseous water. And that requires the heat of vaporization of a mole of water at 100 degrees C, which is around 40 kilojoules. So by far, the most amount of energy is required in step C. Now we can see that reflected in our heating curve. If we go back to the heating curve, you can see that first step, there's the heat of fusion melting ice, about a 6 kilojoule change, and then the heating of the water, around a 7.5 kilojoule change, but then vaporization, a large 40 kilojoule change to change the temperature. So our heating curves help us map out these changes in enthalpy and track changes in heat and temperature.